lines represent the top. This bottom number line represents the denominator. Okay? So it's this times this divided by this. So anywhere there's a 0 on the bottom of this number line, because this is where the values are, as Michelle clarified, and that means that's the point where we're dividing by 0. It just happens to be in the middle here.
But you can't divide by 0.
Correct. That's why I wrote asymptote instead of positive, negative, or 0.
Right.
Because that's what happens when you can't divide by 0 in a graph. I'm going to do one more of these, and I'm going to try and make it behave a little bit differently so that you can see the range of possibilities. Okay, no, that'll be the bottom. Let's see. Do I want to do that? No, maybe. Thinking. Now. Okay, this one will be fairly simple, I think.
It's kind of nerdy as well.
It is. Strangely enough, I find it helpful.
I don't think I saw that straight.
Okay, f of x equals x over x squared minus 16. How can I break this one down?
X over x squared. X over x. I can do this.
Later that evening.
No, x minus 4.
X plus 4x minus 4.
Yep. Okay, Michelle and Sam have this one. You guys with us?
So wait, is this going to be an indeterminate form?
No, indeterminate form will only show up if there's a 0 over a 0. But if not, I'll do one of those because those are fun too. Okay, x squared. This is a x over x minus 4 times x plus 4. When does the numerator equal 0?
When x is 0.
So then x equals 0 is my x-intercept.
Wait, the numerator.
When the numerator equals 0 is an x-intercept.
Isn't the numerator the one
On the top.
on the top?
Yes. All right. My vertical asymptotes are when the bottom equals 0. Where are my vertical asymptotes?
Negative and positive 4.
Yes, vertical asymptotes are x equals plus or minus 4. You guys, gentlemen, you with me up here?
Yeah.
Okay, making sure. Good. My y-intercept is when x is what I get for y when x is 0. Put 0 into this, what do you get?
Yeah, 0 over negative 16.
0 over negative 16, which is 0. So it's going to go through the origin.
I thought that was not possible. I thought you said
Nothing
that,
is
like,
possible.
I thought you said that, like,
When there's a will, there's a way.
That's
yeah,
right.
when you have, like, you're plugging in the 0 for x and you're, like, dividing over it, I thought you said that it has to be, like, non-something.
A 0 on top is fine,
But the 0's on the bottom, too.
but they're not at the same spot. If I put in 0 for x, I get 0 on top, but as Sam pointed out, I get negative 16 on the bottom. 0 over negative 16 is just 0, that's fine. 16 over 0 would be a problem. It'd be undefined. That'd be an asymptote. And 0 over 0 is indeterminate form. That'd be a buttonhole. And those are the 3 real possibilities we've discussed. Okay, horizontal asymptote. Jesse, what's the rule say? Figures. Okay, guys. Jesse is out of the room. He's the one who best remembered the rules for asymptotes. What is the status of the horizontal or slant asymptote of this function and why?
Isn't it that,
Jesse.
Oh, the
The
X
top-
is
the top
below,
has-
so it's like slanted.
the
not
top
slanted,
has to
it's
be
not
smaller
slanted.
than the bottom?
Okay, there's a lower degree on top than bottom. So what did I say for that one?
So then it's
Horizontal.
No,
It is a horizontal one. Which one? There's 2 possibilities of horizontal asymptotes we discussed.
it's the left. No, wait.
Was it left or right? Nope.
Up or down?
Oh my God. Okay. If the numerator is a lower degree than the denominator, the horizontal asymptote is the x-axis, which is also the line y equals 0. If they're the same degree, it's the ratio of the leading coefficients. Remember that?
No.
Yes.
Yeah.
God in heaven, I hope so. Okay. Okay, so that's a horizontal asymptote at y equals 0. Sign analysis now. My
Hi,
3
Jesse.
factors. Jesse, we had to do a horizontal asymptote question without you, and the results were depressing.
Why? I remember.
What will the horizontal asymptote of this one be?
4.
Nope, that's vertical. Horizontal.
Positive 6.
Degree.
Oh, 1. No.
Oh, now I'm really impressed. It was y equals 0. If it's a degree less is on top, if the lower degree is on top, Jesse, then it's the y equals 0. No,
Are you sad now?
I'm very sad now. You were talking about something to the left. I don't know what you were saying.
What we're going to do on a test of that.
Okay, now, I'm taking my three factors. Okay, to be clear, on the top of these number lines, I am writing the values for x. Okay, on the top of these number lines, I am writing the values for
Oh,
x.
this graph is weird.
Probably will be.
So the horizontal asymptote is whatever the degree of the new.
No.
Wait, I'm
Guys,
why'd you write 5?
once again, the three rules for horizontal asymptotes are lower degree on top, it's the x-axis.
Higher degree on the bottom.
Higher degree on the top, and it's a slant asymptote. If it's higher degree by 1, and you have to do the long division. Same degree on top, it's the ratio of the leading coefficients. It's y equals that number.
I can do later.
Wait, why'd you write a 5?
Because I was getting distracted by all the asymptote stuff. Okay, now, here are my three factors. Eli, stay with me. Okay? First one is x. When is x negative? When is x positive?
When x is positive, when it's
This is so simple, it's almost a trick question.
x
Wait,
is positive, when x is
Four.
positive.
No,
Yes,
no.
I know.
It's the positive 4, negative 4.
Right, we're just looking at x right now.
Is it just
Why
negative
not?
to 0 then
When
positive?
x is positive,
one.
x is positive.
Yeah.
Yeah, when x is negative, you have a negative number. When x is 0, x is 0.
When x is positive,
And when x is positive, That sounds dumb, but it's the truth. Okay, x minus 4. When does this statement, guys, the cross chatter is ending now. You're getting tested on this on Tuesday.
Oh, yeah.
For this one, when will this x minus 4 give me a positive, negative statement, or 0 value?
If it's
When
above
x
4, it's
equals
positive.
4.
If it's below negative 4, it's negative.
Correct. So I wrote this incorrectly, didn't I?
Yeah, you
4 over there, and then the 0's below, and then the rest are negative, and then the rest are positive.
Michelle, I actually understood that.
So,
Yes.
if it was negative 4, would it be positive past negative 4 or would it be positive past 0?
For which one? I had these two backwards.
Okay, well, yeah, since it's going to be negative 4 for the bottom one, it's going to be negative up to negative 4, and then it's going to be positive past negative past
Correct.
negative 4, or is it going to be positive past the 0?
It's going to be positive past the negative 4. Because for this, yeah, if I put negative 2 into here, I still get a positive number.
Alright.
So that will stay, this will be negative up to the negative 4, then it'll be 0. Then it will be positive all the way up from there.
So you have 3 zeros for this one.
I had 3 zeros for the last one too. But you got to ask yourself, what is going on with f of x? How are these three things related to each other? Now on my f of x number line, I line up the 0, I line up the negative 4, I line up the 4.
What does the f of x one go for?
The f of x describes the sign, positive or negative, of the entire function. So you have to look at how the function relates to three factors. Okay? This one relates to three factors by having the x on top, and these two are on the bottom. This is what you're dividing by. So we have a negative divided by a negative times a negative.
Wait, how is the first one
Whoa,
negative?
isn't it negative times a negative
So it's a
divided by a
negative.
negative?
When we're less than 0, when we're over on this side of the number line, x is negative.
So it's a negative.
Yeah, so this is going to be a negative divided by a positive. So it's going to be negative until I get, whoops, I'm writing the values on the bottom. I want to be consistent.
Wasn't the pattern, isn't it times each other and then the third is divided by?
It's whatever is happening in the function zone. In the last function, it was multiple.